Hi everyone. So today we're going to talk about the evidence behind the Big Bang Theory. But first, we need to talk about light, the electromagnetic spectrum. So we said that the universe is expanding. And if you think of the universe as a balloon, then the universe is expanding kind of like the balloon. And now, if the universe is expanding, then the light that was coming from the beginning of the universe, that wavelength of light must have also expanded, kind of like this. Say the wavelength of light coming from the early universe, say in the early universe there was a distant star back then. That light coming from that star, or even the Big Bang, must have expanded, or the wavelength must have expanded, and to become this, and then this, and then this. And remember, as different as light has different wavelengths, it either increases or decreases. We get different types of light in the electromagnetic spectrum. Kind of like how red has a longer wavelength than violet, and radio waves have a longer wavelength than infrared. And you can find this in your reference table, page 14. So go ahead and write this down in your note packet. On the reference table, page 14, we can find the electromagnetic spectrum. Now, how does this work? Well, if you've ever seen a rainbow normally happens when it rains outside, and that's because the water droplet takes the light from the sun, and as light passes through the water droplet, the water droplet splits it into the colors of the rainbow. And you'll notice that each color of the rainbow has different wavelengths of light. Red has a longer wavelength, violet has a shorter wavelength, and it's a spectrum. And now scientists figured out that if you pass light through a gas first, any gas, and then split it into the colors of the rainbow, you'll see black lines in the rainbow. That's because different types of gases actually absorb different wavelengths of light. In this case, this particular gas absorbed the green wavelength of light, and that's why in the rainbow we don't see green, but instead we see a black line. And this is important because remember, stars are massive balls of gas. They create their own energy. But when light comes from stars, they actually have to pass through the gas from that star before reaching us. And scientists actually use that to our advantage. When the light from a star is coming towards us, that light is passing through a gas, right? That particular gas from the star must have absorbed some of that star's light. So when that star's light comes to us, we use a device called a spectroscope to split that light into the colors of the rainbow. And we can see different black lines on the rainbow depending on what gas that star is made up of. And this helps us figure out what the elements or what gases are in the different stars in the universe. And what we notice is this. Say I have a laboratory reference of hydrogen in the lab, right? And I know hydrogen gas, if I pass light through it and then create a rainbow, I'll see these black lines in these specific areas for hydrogen because hydrogen absorbs these particular wavelengths of light. But what we also noticed is if we compared the hydrogen in the lab on Earth to the hydrogen in a nearby star, galaxy, distant galaxy, and so on, because all these galaxies and stars also have hydrogen, and when they're giving off light, that hydrogen is also absorbing the light there, and it should cause the same exact black lines. But instead, we're seeing the same pattern of lines. We're still seeing hydrogen, but those lines are starting to shift towards the red side. And we'll talk more about this in our next video.